Okay, so let's see how you did. We were interested in developing an equation for the radius of an atomic bomb fireball as a function of some independent variables. So our function of the radius, as our radius is a function of time here, which is one of the reasons I wrote it r of t. You could just replace that with an r on the left side if you wanted. And then on the right, we have our variables, our energy of the explosion, our density of the air, and the time involved after the explosion, and raised to unique powers of, and again, I just chose x, y, z. All right. The second assumption is it will, and I hope I included this in the handout, is that the density of air we're going to assume is 1.293 kilograms per cubic meter. That's a fairly common, I mean, that's considered to be the density of air, I guess, at probably standard atmospheric pressure and temperature. Um, so anyway, writing that equation again and following this dimensional analysis, if you did it all right, you should have received, or you should have not received, but you should have derived an equation that looks like this one at the bottom. The radius of the fireball is going to be equal to the energy of the explosion over the density of the air to the 1/5 power times the time to the 2/5 power. Okay, so if you didn't get that, go back and look at your work, okay, because I want to see this work, pretty much what's shown here. I want to see you do that out, and you hopefully will end up with that equation at the bottom there. Now, once we have the equation, what we have here, if you remember, we've got an equation, and um, pretty much the idea here is that we're going to make a graph. Now, if we graph on the one part of the graph, let's say on the, let's see here, if you graph the radius, I believe, along the vertical, and we do time to the 2/5 along the x-axis, then this would be our slope. So in other words, the equation of a line is y equals mx. All right. So basically, our y is going to be our radius. Our x is going to be time to the 2/5 power. So you're going to want to take your data that you recorded in your data table there, and you should have the data table with different radii at different times. You're going to want to take your times to the 2/5 power. All right, you're going to want to make a column. So in other words, in your data chart, you'll have, like your radius, your time, and then your time to the 2/5 power. So you'll have to use your calculator or Excel spreadsheet if you know how to do formulas in there. And you'll have to take your times and make a new column that's time to the 2/5. Then what you're going to do is make a graph of the radius versus the time to the 2/5 power. Okay, so along the x-axis here, you're going to graph t to the 2/5 power. When you do that, you should get a pretty much a linear graph. Okay, and you're going to do a curve fit, and then the slope m of that equation obviously is going to be the energy of the explosion over the density of the air to the 1/5 power. And so knowing this, right, and measuring this from your graph, you should be able to ultimately figure out the goal of the experiment, which is to determine the energy of this Trinity bomb explosion. Okay, if you read up historically on this, there was a physics professor, Life magazine published a series of photographs from that experiment, and a couple years after that Trinity test, after the end of World War II, and a physics professor from those pictures did exactly what we're doing here and determined the energy of that atomic bomb explosion, okay, which is kind of pretty neat. And he, of course, received a quick visit, I'm sure, from the military. So anyway, I hope you can finish up the work. It should be a hop, skip, and a jump from here. Turn your work in on Monday in lecture. And again, one submission per group, please. So if you worked with 3 or 4 or 5 people, put all your names on the report. Use the cover page document. That's the cover page document that's in the lab module. Customize that for your group. Um, Provide the things that are needed for the report as indicated in the handout, and end your report, have a printout of that grading rubric that's posted in the lab module as well. and staple that stuff together, have it ready to turn in on Monday in lecture. All right. Have a great weekend. Well, actually, I'll see you Friday in lecture. If you've watched this before Friday at lecture, I'll see you in Friday lecture. If you're watching this after lecture, have a great weekend, and I'll see you on Monday. Thanks. See ya.